Okay, let's go with my presentation. Okay, so okay. So hello and good day to all who will be watching this video. I am Mered A. Lucero, a BSEC student of LPU Laguna. Okay, so this is my outcome evaluation in electronics to electronic circuits analysis and design. So this the topic of this video is what I researched, learned, and understand about transistor. Okay, so let us go with this for course outline of this presentation or objectives. For the objectives, I have here a 7 item. First one is the history of transistors. Second is importance of transistors, definition of transistor, its structure and operation. Tip one is the transistor types and symbols. Six is the application of transistor, and lastly, the conclusion. Okay, so let us go first with the history of transistor. So 1906, it was all started when American inventor and physicist Lee De Forest invented the vacuum tube triode audion. So it is used in the early radios and computers. Then year 1946, it was a huge leap in this history of transistors and also about electronics uh, when people of the past invented the first electronic computer. So this one is called the ENIAC, and it was consists of 20,000 vacuum tubes weighing in 30 tons, and its relay input cards was used and with the 5 kilohertz speed. So after that, the first of its own device, the point contact transistors were made and developed by scientists John Bardeen and Walter Brattain by the Bell Labs. Then after that, uh, the main contributor for this development of transistors were the Bell Labs, and it sets up scientists behind this development of transistors, and there are so many names to be familiarized with this, such as example is the first one, John Bardeen and Walter Brattain. We should also be acknowledging their partners, such as Cooper and then Schrieffer and so many more. Then let us go again with this um with this timeline. So year 1949, the first junction transistor were made, and it was developed by William Shockley, also by the Bell Labs. So it was created for easier fabrication and overcomes the vacuum tubes. So it was also a huge leap in this history of transistors. Then another one, in year 1954, the first working silicon transistor were made, and it was developed by Mons Tannenbaum, also by the Bell Labs. Then uh, lately, uh, there are so many just like what I'm saying earlier, there are so many scientists behind this one, such as the names that I dropped before. And by that time, they are completely separated. And the first one who developed this was John Bartin. And due to his development that time, he get a Nobel Prize for that. And another one is William Shockley. So just like what I was saying earlier, he for the for the overcoming of this vacuum tubes, he was also uh, he was also developed the semiconductor and the BJT, or the bipolar junction transistor. So after that, they are separated, and G Moore. So and Robert Noyce. So that's name. There are the main co-founder of the Intel company, which is the uh, famous these days in terms of this in terms of this electronics device development advancement, and they are the one who were truly behind this development. And then by that time also the 1954, the Regency TR1 and the first transistor radio by the Texas Instruments were developed. And just like what I'm saying earlier, 1965, Gordon E. Moore, also from the team of John Bardeen by the Bell Labs, and now the and that time become the founder of Intel, predict that the number of transistors inside an integrated circuit will be doubled every 24 months, and the density minimize the cost of that transistor. So by that time, scientists and developers of these transistors were challenged because of this Moore's law and in Moore's law and prediction of this G-Moore. So by the time the continuous development RDD of this transistor were become so aggressive because of this Moore's law. And by that time, the year 1971, the Intel, which is the uh, founded company by Moore's law, including Robert Noyce, developed the world's first microprocessor. So why am I introducing microprocessor here? Because microprocessor is an example of device that has the maximum number of transistors inside. So this Intel Core 1004, the first microprocessor, includes in their development the cutting edge silicon gate technology. So what does that mean? So uh, many transistor is equals to more pass. Parang ganun lang siya. Okay. So then the continuous development and of these transistors and the semiconductor technology and electronic technology were continuous nowadays. And there are so much names to be dropped, but I am not going to say that all, but would like um to include some. Yeah, just like what I'm saying earlier, the Intel, Jack Kilby of the Texas Instrument, Dawon Kang, Martin Atalia of the Bell Labs, because they invented the MOSFETs, which is also a family of these transistors. Fujio, Masuoka, Toshiba, first invention of both uh, NOR or NAND flash memory, and Nick Holonyak, GE, and Shushi of Nakamura Nichiya, first invention of LED. So these are all family of these transistors and electronic components. So that is why we are so much thankful to them. So what is now new with this transistor? So just like what I'm saying earlier, the microprocessor with the most number of transistors inside, and it was named Apple's ARM-based M1 Ultra. So this is a chip produced by the Apple, and it contains 114 billion MOSFETs or MOSFETs, field effect transistors, and um, this is fabricating using a TSMC's 5 nanometer semiconductor manufacturing process. So this is truly a small part with billions of transistors inside. So that's why imagining the advancement in technology of this companies and peoples. So by image and by parameters, this is the M1 Ultra looks like. So M1 Ultra has a 5 nm up to 128 gigabyte unified memory, and would like to emphasize this, the 20 core CPU and 64 core GPU. So imagine the past transitions and and ultra processing of these devices. And this device or microprocessor. So definitely, this is really expensive. Okay, so that is all for the history of transistors. So let us go with this importance. So transistors are considered to be essential to an integrated circuit. So we all knew of that. And most of all electronic devices, we are using such television, PCs, cellular phones, smart cities, and advanced technology cars uses transistors. So basically, transistors is everywhere on your electronic devices. So, and lastly, transistors will always be a key component in the development in electronics field. So I know they are still improving this one, and transistors will is really such an essential thing for that. Okay, so let us go with the next slide. So let us go with the definition of transistors. So transistors is the combination terms of transfer and variable resistor, which means that transfer of current across resistor. So that's basically the meaning and function of this transistor. So also, it is a three-terminal electronic device made up of semiconductor material. Then it consists of two p-n junction formed by either sandwiching p-type or n-type semiconductor between a pair of opposite types. So this part, I will be discussing this later on the next slides. And because there are images for this. And another one definition is it can act as an insulator conductor. Then another one is can be used as a switch, voltage regulator, amplification component, and modulation of signals. Okay, so this typically the definition of transistors. Next one, I sorry, I forgot to state this one. Um, forgot to state this one. So these components here are all types of transistors, and this may vary in their function and in sizes. So sizes may vary because of this capacity for each of these transistor. Okay, so let us go with the next slide. So structure and operation of transistor. So we have here for the transistors terminal. So this is typically what our transistors looks like. So it contains a three terminal. So we have here the collector, the base, and the emitter. So what are the functions of each? So emitter, heavily doped, can emit large number of charge carriers. So we all know that charge carrier within a p-type and n-type junction are always electrons and holes. So what are these? So holes are positive and electrons are negative. So another one of the transistor terminals are base. So base are lightly doped and very thin so that it can passes charge carriers to the collectors. Then lastly, the collector or moderately doped collects charges carriers again once they have passed through the base. So another one to discuss here are the regions and doping. So these are all already included here. Emitter is heavily doped, base is lightly doped, and collector is moderately doped. So inside, this is the image of what these regions of doping regions are. So basically, this one is the this one is the emitter, this one is the base, and this is the collector. So they have here a p type. So both emitter and collector are p type, and base will be the negative one. So this is a PNP type. So what is the function of these regions are? So regions and terminals are. So basically the emitter, so it is the main force that or the main force of this circuit. So by analogy, we are using this we are using the analogy of grip ng gripo natin or our our water supply for this for the use of these regions and terminals are. So we have here the main supply which is passes to the emitter, and we have here the base which controls the flow, and the collector which is the final output. So basically, this is the analogy of the use and function of transistor. So another one to be discussed here is the operating regions of a BJT or a transistor. So BJT means um, bilateral junction transistor. So basically, we will be discussing this as we go through the slides. And so there are three types of operating regions within the bilateral junction transistor. So these are the cutoff region, linear region, and saturation region. So basically, since we are using this, yung gripo natin as an analogy for this, uh, if we if this is fully, kumbaga kung yung gripo natin ay fully closed, then it functions as off, and there will be no flow of current or no flow ng tubig dun sa ano natin. So by output, there will be no current within the circuit. Another one is the linear region. So this is also sometimes called the active region. So this is in on state and intermediate control of current flow. So this is variable because you will be the one to control this kumbaga ikaw yung nagko-control ng pagbukas ng ating gripo. Then lastly, the saturation region or the pull on state of this transistor is allowing the full current flow or the maximum current to flow within this transistor. So basically, this is the regions that we have here. So cutoff region, so it function as in terms of digital output, it is function as 0. Then linear region, it is a variable condition. So kumbaga not fully determined. Then lastly, saturation region which is equal to only to 1 or lagi lang siyang buhay. Okay, so transistor biasing naman. So transistor biasing is the base emitter BE junction is in forward bias. So we have here na example here. Forward bias siya kung this will be the base, this will be the emitter, and this will be the collector. Forward bias siya because the polarity, we all knew of that. If the polarity or the positive terminal is going to the base, then since this is an NPN ano siya, hindi lang masyadong makita dito sa ating percentage sa ating maliit na image here. Since na positive to at pumapasok siya dito sa ating P-type P junction, so that is the reason why they are in forward bias condition. If negative, then pumapasok siya dito sa base natin na ang kanyang ay negative, naging din siya, and then din siya, kumbaga magpa-function as forward bias. So dahil positive terminal to positive junction, then it acts as an forward bias. Okay, so we have here the base collector or the BC will be in reverse bias since magkasalungat sila. Okay, so let us go. So basically, this is the structure and operation of transistors. Next one will be the transistor types and symbols. Okay, so we have here, just like what I'm saying earlier, the unipolar junction transistor or the UJT, the bipolar junction transistor BJT, and field effect transistor FET, and metal effect semiconductor or MOSFET. So let us discuss each. So for the unipolar junction transistor or short for UJT, it uses only one type of charge carrier. P-type or N-type semiconductor from the single. So the PN junction within the main conducting N-type channel or device. So this is an sample. This is the symbols for N channel and P channel unipolar junction transistor. So it is also a solid state three-terminal device that can be used in gate files, tiny circuits, and triggers. So what we have here, so this is the emitter, this is the base, and this is the base 2. So basically, for their difference, um, N channel, so since dito pumapasok yung ano natin sa base, ang ilalabas niya, dito lang siya, dumediretso lang. So look out for this arrow. So the arrow is the difference of this one. But all through this presentation, we will be more tackling or more focus our activity um and our concept and ideas to bipolar junction transistor, because this is the most common use, most especially in hardware devices for our TVs and ano, because this field effect transistor and metal oxide semiconductor, or sometimes they are MOSFET. They are in semiconductors or integrated circuits application. So another one is the bipolar junction transistor or the BJT. It uses both electron and hole charge carriers. So use two junction between two semiconductors, N-type and P-type. So we all know of this. When we say N-type, the majority carrier will always be in electrons, and in P-type, the majority carrier will be holes or the positive one. So there are two types. So just like what I'm saying earlier, we have the NPN and the PNP type. So later we will be discussing these two types. And bipolar junction transistor functions to amplify current, thus can be used as a switch and amplifier. So its main function is to amplify current. So amplification of current yung kanyang pinaka-function. So that's why it can act as a switch and amplifier at the same time. So we will be, just like what I'm saying, we will be widely using this since BJT is widely used to electronic devices. We'll be more tackling this or more focuses our presentation with this one. Okay, so let us discuss also this field effect transistor or the FET. So this is the symbols for this type. It uses electric field to control shape and conductivity of channels of one type carrier or unipolar. So this is somewhat related to this unipolar junction transistor because it only uses one charge carrier only. So amplified field effect transistor, also amplified input voltage, imposes an electric field which attracts or repels charges to or from region between source and drain. So we have here the drain and the source. This one will be base and base 2. But basically their function is almost the same. So they are also saying here that density of charge can in turn influence conductivity between the source and the drain. So basically, the main difference with this one is it functions only on electric field, and this one is more of a the flow of current, but this one is more of an electric field siya, nagpa-function. So this also is the metal oxide. Another one is the metal oxide semiconductor, or the metal oxide semiconductor field effect transistor, or this is more popular into MOSFET, used for amplifying or switching electronic signals. So MOS is a method of creating transistors, and it consists of 3 layers: metal conductors, insulating silicon layer, and semiconductor silicon layer. So just like what I'm saying earlier, we will be not focusing ourselves into this one, but this is really an essential tool in developing semiconductor devices. most especially in integrated circuit. Okay, so let us go for the next slide. Okay, so just this is the bipolar junction transistor. So just like what I'm saying earlier, it consists of a two junction pairs of PN junction. So diodes that are joined back to back and thus form a sandwich where a kind of semiconductor placed between two others. Okay, so by image, this is the two pairs of PN junction means. So we have here a two pairs, and in terms of equivalent circuit, this is what it looks like. So NP and PN. So so since common yung gitna nila, it can be used and simplify into this image. So basically, that's function as the PN junction, two PN junction. So the first one is the NP and the other one is the PN. So two PN junction pa rin siya. And its symbol, when in NPN, so um, so this is what it looks like. So NPN siya. Itong ang ating magiging ang P natin dito will be the base. And this will be the emitter and this will be the collector and this will be the emitter. Since goes to this, but um uh the equivalent circuit will be um different. So PNP, this become the simplified image, and then the function will be here. So this will be the base, and this will be the positive. This will be the the P type junction or the emitter, and lastly, this will be the collector, which in P then. So there are two types of NP. There are two types. So this is what I'm explaining earlier. So in terms of structure, this will be the image. Yan, meron pala dito. So ang NPN natin, ito, magiging N-type siya. Ang ating base naman ay E-type and emitter natin will be N-type. So that is why ang ating magiging symbol is just like this. So yung base natin, P-type, ganyan ang itsura niya. Dito siya. So ito yung equivalent circuit niya. Then another one is the PNP. Collector will be P-type, base will be N-type, and emitter will be P-type. So this will be the equivalent circuit of this. So how does this function? So in NPN circuit, so this is the positive terminal, and this is the base, and this is the so they are all also the same. So this is the base, this will be the emitter, and this will be the collector. So dapat i-connect lang natin siya dito sa, kung may battery tayo dito, so magiging ganyan siya. Connected na natin siya dyan para maging forward bias siya. Then, same goes to this. So this is more of naming the transistor natin kung anong type siya. So completely magkaiba sila, magkaibang, kumbaga kung meron kang dalawang item, kung yung pangalan ng ano mo ay NPN lang talaga siya. Then yung transistor natin isa naman kung nasa datasheet niya na PNP siya, PNP lang po talaga siya. So that's the kumbaga kung meron tayong actual item, magkaibang unit sila. So yun ay magdedepende pa kung paano mo sila kakontrolin. Okay, so another one, let us go with this application of transistors, and this is the application of transistor as a switch. So transistor as a switch can be used to switch low voltage DC device on or off by using the transistor saturated or cut-off state. So we have here this is the we are all familiar of this. We are all familiar of this image. This is the hyper characteristic. So this is the voltage and this will be the current. So since we are using or we are using the transistor as a switch, the switch only function in this state. So we have, this is the saturation region and this is the cutoff region. So this shaded part will be the saturation and cutoff region. So our device or our transistor will only output at 0 or 1. So what that does mean? If the voltage is not, if the voltage is na, not having the the sat enough voltage for the transistor to be switched on, then it is in up. And if nalampasan niya na yung ano na yon, yung voltage na yon, magiging ano siya, magiging on state lang siya. Kumbaga, it is a matter of on and off lang po. So, what is this enough voltage to switch our transistor on or off? So, since we are talking with this on and off of transistor or as a switch, we are defining into the cutoff region and saturation region. Okay, so transistors operating in zero input base current, output base current, and maximum collector, kumbaga lahat sila ay zero, magre-result lamang siya sa mas mataas na depletion layer. So we all familiar of these terms because diodes uses also these terminologies, and no current flowing through the device. So that transistors as a switch is fully off. So just like this is a sample sample circuit. So we have here I think this is an NPN. So since connected siya sa zero, ang ating base, this will be the supply. The main supply, this is positive and this will be the negative one. So since connected siya sa zero, ang papasok sa ating sa ating base ay zero din, then ano lang siya, kumbaga hindi mo pa siya ina-applyan dito ng ano na mahihigitan niya tong 0.7 volts since we are using silicon type transistor here. So since less than pa yung voltage na ini-input natin sa kanya to 0.7 volts, then mag-aano lang ang ating ang ating mananatili lamang siya sa pagiging sa kanyang cutoff region or sa kanyang off state. So ganun po siya nagpa-function. So anything na lalampas dito sa ating, kung ang ating sinusupply sa kanya or ang ating VBE is greater na siya sa 0.7 volts or yung sinusupply natin sa kanya mas mataas pa sa 0.7 volts, that's the time na magpa-process na ang ating transistor switch, which mapupunta naman siya sa ating saturation region na only function as fully on. So ganun lamang siya. Doesn't matter kung ano na yung voltage mo sa kanya. For example, only 0.71, nasa fully on condition na siya. Kung 0.69, nasa off condition lamang siya. Pero that is only that is only just to make you that is not an exact values, but that is only just to imply may understanding with this. So as long as hindi niya nalalampasan ng 0.7 volts, naka-off state siya. Kung lumampas siya, naka-saturation region naman siya or on, fully on. So that is the function of this switch. Okay? So kapag open yung connection, then kapag kumbaga open yung switch, kapag off naman siya, kumbaga itong ano na to, then ito pong part na to is considered lang siya as ganito. Then ito namang part na to This one is connected in positive supply. So, kung positive supply siya, kino-consider niya naman siya as switch. Switch closed or naka-close yung switch natin. Kaya, nagpa-function ng ating transistor. So, basically, that's the main concept of this transistor as a switch. Okay? So, another one of the application of a transistor. Okay. Another one of the application of transistor is transistor as an amplifier. So a transistor as acts as an amplifier by raising the strength of a weak signal transistor work as an amplifier while they work in active region or Q point. So this is the another region that I'm talking to earlier. So the main function of transistor as an amplifier is to enhance the input signal without changing much yung ating circuit. Okay? So basically, this is from zero yung voltage natin. Kumbaga, anything na magbabago doon sa ating supply is makaka-apekto fully doon sa magiging output natin. So that is why dito siya nagpa-function sa region na to. So habang tumataas yung dinadagdag mo, so meron na siyang uses ng external voltage para mag-function tong ating natin. Sorry, medyo na ano ang aking back. Control Z. Yeah. Erase. Okay. So basically, yun yung function ng ating as an amplifier. Dito naman tayo nagpo-focus dito sa area na to, yung wala siyang shaded part. Okay. So how does that happen? So basically, we have here an example of an image of a circuit diagram of a transistor uses an amplifier. So we have here the base. This is the base part. This is the emitter, and this is the collector part. So input is connected in forward bias condition. So we have here forward bias condition. This is positive going through here. And whereas the output voltage is connected in reverse bias. So ito namang output natin, reverse bias condition naman siya. So generally, the input circuits includes low resistance as a result. A little change will occur in signal voltage at the input, which leads to a significant change within the emitter current. Because of the transistor act, emitter current change will cause the same change within the collector circuit. So also, the flow of collector current through an RC generates a huge voltage across it. Therefore, the applied weak signal at the input circuit will come out in the amplified form at the collector circuit in the output. So just to make you understand this text here are, I have this actually hindi siya na-play po, pero I'll try to explain as much as I can yung understanding ko po dito. So una, so this is ito po ang ating transistor. So basically, this is an external source, and this is ang ating initial source. So we have here the emitter at this part, and this is the base, and this is the collector part. So typically, hindi siya masyado nakaka-apekto pa dito sa ating condition kung hindi pa ito nakakabit. So unang-una, since NPN ang ating type ng ating transistor, we have here a small battery. So small battery here. Kumbaga mas maliit lang siya yung ating source here. So just like what I'm saying earlier, hindi pa to kasali dun sa initial circuit. So since this is the battery, this will be the positive terminal. Then this is the negative terminal. So current will flow here initially, then pushes. Since this is an n-type, there are so many free electrons in this part. Thus, pinupush niya tong mga positive holes natin. Thus, mag-iiwan siya ng mark here. Yung mga positive natin dito, pupush siya papunta dito. Okay? So, dahil konti lang yung space niya dito, yung ibang mga electrons dito, dahil sobrang dami nila, pupunta na siya dito. Then, magpa-process siya. Dahil kita niyo naman po dito na ang ating polarity will be ganito. So, kaya nangyari na napupunta dito dahil maliit lang siya. Yung iba dyan, may higop nito dahil ano siya, positive siya. Dahil ito ay electrons na, pupunta siya dito dahil positive. Maraming ano po maraming holes kasi hindi siya makakaikot lahat. Maraming negative, sorry. This is negative. So madaming electron siyang sobra, makukuha nitong positive natin. Dahil magi-interact siya. So ibig sabihin, ang magiging flow ng ating current here will be just this one. So imagine the flow of current here and the supply here will adds up. That is why nagpo-produce siya ng mas mataas na output. So literally by analogy, that's the concept of amplifier. So yung source natin dito and source natin initially here is mas maliit compared dito, and dahil dun sa flow ng ating charge carriers, nag-adds up sila para makapag-produce sila ng mas mataas na voltage or current, mas mataas na current na nagiging reason kung bakit na-amplify yung ating output. So, bali ganun po siya nagpang-function yung ating transistor as an amplifier. So, hopefully, medyo clear siya dito. So, tatry po nating mas explain ulit. Okay? So, initially, this is positive, negative. We have here the positive and the negative. So, this is an n-type terminal. The flow of current will be here. So, there are so many electrons here of negative, which is the reason why yung iba dito, mag-flow na siya dyan. Dito, may mga maiiwan na hole. And dahil nga mas madami to, yung ibang negative, mapupush dito. Dahil meron tayong additional additional source here na mas malaki ang value kaysa dito sa ating initial source. This is in positive. That is why i-attract na siya lahat ng negative ng lahat ng electron charge carrier here. That is why mapaplas siya sa ating initial current here na magpo-produce na mas mataas na current na magpo-continuous na yung loop. That is why mas mataas ang current here compared dito sa ating initial na input. So that's why this amplification of transistor happens. So this is by an analogy. This is by concept wise only, but this is much more complicated since much more tasks in complicated tasks here because it has an computation to be done with this one and sets of formulas for this one. Okay, so let us go with the last slide because I think I am going to I'm taking long enough. So for the conclusion, so transistors are semiconductor device used in amplifying, controlling, and generating electrical signals. And transistors are the active components of integrated circuits or microchips. which often contain billions of these minuscule devices etched into their shiny surfaces. And transistors is used in wide range of applications, including amplification, switching, either digital or analog, regulator in voltage, current, and power, buffer or impedance matching between mismatched circuits, and used in building blocks of integrated circuits. So basically, this ends my presentation for this transistors. And thank you all for watching until the end. And God bless everyone. Salamat po.